In this article, we study about what is the exact differential equation. So, a differential a differential equation of the form a differential equation of the form m dx plus n dy is equal to 0, where m and n are functions where m and n are functions of x and y or constant, then is said to be is said to be exact if a differential equation of the form m dx plus n dy is equal to 0, where m and n are functions of x and y or constant, is said to be exact if left hand side of above equation can be obtained by directly differentiating some function of some functions of x and y. Here a differential equation of the form m dx plus n dy is equal to 0, where m and n are functions of x and y or constant, is said to be exact if left hand side of this equation can be obtained directly by differentiating some function of x and y. If f(x,y) may be such function of x and y, then differentiation of f(x,y) is equal to m dx plus n dy, that is del f upon del x multiplied by dx plus del f upon del y multiplied by dy is equal to m dx plus n dy. Here we know that if differential equation of the form m dx plus n dy is equal to 0, where m and n are functions of x and y or constant, then this equation is said to be exact if left hand side of this equation can be obtained directly by differentiating some function of x and y. If f(x,y) may be such function of x and y, then differentiation of f(x,y) is equal to m dx plus n dy. When we differentiate f(x,y), we can write is del f by del x into dx plus del f by del y into dy is equal to m dx plus n dy. Now we solve the differential equation. X square minus ay minus ax minus y square dy is equal to 0. So first we compare this equation by m dx plus n dy is equal to 0. Here m is equal to x square minus ay and n is equal to minus ax plus y square. First we compare the given differential equation with m dx plus n dy is equal to 0. So m is equal to x square minus ay, because here the coefficient of dx is m, here the coefficient of dx is x square minus ay. So m is equal to x square minus ay. Here the coefficient of dy is n, here the coefficient of dy is minus times ax minus y square. So n is equal to minus ax plus y square. Now first we find the given differential equation is exact or not. So first we differentiate partially with respect to y. first we differentiate m partially with respect to y. So when we differentiate x square minus ay with respect to y, we get differentiation of x square is 0 because x square is constant with respect to y, and here a is constant and differentiation of y with respect to y is 1. So del m by del y, this is equal to minus a. Here first we differentiate capital M with respect partially with respect to y. So del m by del y, this is equal to 0 minus a multiplied by 1, because differentiation of x square with respect to y is 0, because when we differentiate partially, so x is constant with respect to y, so differentiation of x is 0. Here a is constant and differentiation of y with respect to y, this is 1. So del m by del y is equal to minus a. Now we differentiate n with respect to x partially. When we differentiate n with respect to x partially, so y is constant here. So when we differentiate this minus ax, so minus a is constant and differentiation of x is 1, and differentiation of y square with respect to x, this is equal to 0. So del n by del x is equal to minus a. Here we can see that del m by del y is equal to del n by del x. So the given equation is exact. So the given equation is exact. So first we compare the given differential equation with m dx plus n dy is equal to 0. Here coefficient of dx is capital M. Here coefficient of dx is x square minus ay. So m is equal to x square minus ay. Here coefficient of dy is n. Here coefficient of dy is minus times ax minus y square. So this can be written as n is equal to minus ax plus y square. Now first we differentiate partially with respect to y to m. So when we differentiate m partially with respect to y, this x square is constant, so differentiation of x square with respect to y is 0. Here this is minus a, this is constant with respect to y, and differentiation of y with respect to y, that is 1. So del m by del y is equal to minus a. Similarly, we differentiate capital N with respect to x partially. So here when we differentiate minus a, so minus a is constant and differentiation of x with respect to x, this is 1, and differentiation of y square is 0 with respect to x, because y square is constant with respect to x. So here we can see that del m by del y and del n by del x both are equal. That means the given differential equation is exact. Now we find the solution of this given differential equation. So solution can be obtained by integrating m with respect to x plus n1 dy is equal to c, where n1 is independent with x. Here n1 is obtained from n, and we take those terms from n which does not belong x. So n1 is obtained from n, and we take those terms of n in which does not belong x. That means n1 is independent with x. Now we put here value of m, that is x square minus ay, and here we put n1. So n1 we obtained from n. So here this is ax. So leave this term and taking this y square. Now we integrate this x square with respect to x. So we get here s cube by 3. Here we integrate ay with respect to x. So we get here axy. Here we integrate y square. So we get y cube by 3, and taking here c1 is constant. So we multiply whole equation by 3. So we get s cube minus 3axy plus y cube is equal to 3c1. c1 is constant, 3 is constant, so the product is also constant. So we put here in place of 3c1 we put here c. So it can be written as x cube minus 3axy plus y cube is equal to c. So this is the solution of the given differential equation. Thank you.